Have you ever stood in front of a breathtaking landscape, snapped a photo, and looked at the back of your camera only to find a washed out sky or a foreground that is completely pitch black? It is incredibly frustrating, but you aren't doing anything wrong. You are just hitting the physical limit of your camera. Even the great Ansel faced this exact same problem. When he hiked through harsh terrain with a heavy, large format camera, he only had a few glass plates with him. He couldn't afford to guess. He had to engineer his exposures using his 11-zone system to make sure he captured the exact light data he needed. Adams was a master of the darkroom. If his negative captured the data, he could dodge and burn the print to reveal detail in both the bright skies and the dark shadows. He was essentially doing HDR manually. Today, we have digital high dynamic range, or HDR, and the histogram. These aren't just new software tricks, they are the modern equivalent of Adams' zone system. And today I'm going to show you exactly how to use them. First, let's define the problem. The human eye is incredible. As you look around, your eyes dynamically adjust, allowing you to see about 20 stops of light. Modern camera sensors are amazing, but they can still only capture around 14 to 15 stops. Think of your camera's sensor as a bucket and light as water. Once the bucket is full, any extra water spills over and is lost forever. In photography, we call that clipping. The solution is HDR bracketing. Instead of taking one compromised shot and hoping for the best, we take a sequence of frames. We take a dark shot to capture the bright sky, a normal shot for the midtones, and a bright shot to capture the shadows. We are simply gathering all the necessary light data. But how do you know if you captured the right data? You use the most important tool in your camera, the histogram. This graph is simply a raw data representation of your exposure. The horizontal axis represents brightness. Pure black on the far left, pure white on the far right. The vertical axis shows you the volume of pixels at that brightness level. Here's what a problem looks like. When the data is bunched up and literally cut off against the left wall, your shadows are crushed. When it hits the right wall, your highlights are blown out. The data is gone, and no amount of software can bring it back. When you are out shooting, set your camera to auto exposure bracketing. You can usually choose 3, 5, or 7 shots. But here is the critical step. Do not blindly trust the camera. Check the histogram for your darkest shot and make sure the right side isn't clipped. Then check the histogram for your brightest shot and make sure the left side isn't clipped. If your data is safely away from the walls on both extremes, you have assurance that you have not lost any image data, but it does not guarantee that you have captured the entire scene. To be sure I have all the data, I increase the exposure until I get highlight clipping. Then I use the exposure compensation dial to reduce the exposure by 1/3 stop. I repeat if necessary until the clipping is gone. I do the same for the shadows. Clipping, increase exposure by 1/3 stop until the clipping is gone. Now we take those files into the computer, whether you use Lightroom, Photoshop, or Photometrics. The software is just acting as your digital darkroom. Its first job is to align the pixels perfectly to fix any micro vibrations and de-ghost any moving elements like flowing water or blowing leaves. Then it merges those files to build a massive 32-bit super negative. Computers work in binary, or powers of 2. A standard 8-bit JPEG has 256 steps of light. The 16-bit RAW file has over 65,000 steps. But a 32-bit HDR file, it holds over 4.2 billion steps of light data. You can't even display that much data on a standard 8-bit screen. That is why we use tone mapping. Tone mapping is the process of squeezing those 4 billion steps back down to a size your screen can show. It acts like a rubber band, compressing the extreme highlights and extreme shadows while leaving the midtones intact. But beware, if you push the shadow and highlight sliders too far, the software gets confused at the edges and you end up with those unnatural, radioactive looking glowing halos. Less is almost always more. So the next time you find yourself facing a brilliant sky and deep shadows, remember Ansel Adams. Don't guess. Use your histogram to verify the data and use bracketing to capture the full spectrum of light. The software is just your digital darkroom, pulling the best details from the files you engineered in the field. But here's the catch. HDR software can only work with the light data you actually capture. If you are flying blind in the field, the computer can't save you. If you want to completely eliminate the guesswork, check out my book, Mastering Photographic Histograms. It shows you exactly how to read that graph so you never accidentally clip a highlight again. And if you need to strengthen your core foundation, pair it with my guide, Mastering Aperture, Shutter Speed, ISO, and Exposure. It breaks down the exposure triangle step by step so you can confidently tackle any lighting situation. You can find links to both books right down in the description. If this breakdown helped demystify HDR for you, hit the like button and make sure to subscribe to the channel for more straightforward technical photography tutorials. Until next time, get out there, trust your histogram, and keep shooting. Let's keep it simple.